get going. I'm gonna start a record.
Okay. Well, so I'll jump straight to the slides, and hopefully you can see these.
Yes, we can.
Yeah, cool. Okay, so basically, I was just gonna talk about. I have an agenda here, and these things would make more sense as I go through them. So basically, in Microsemi, I'm in the frequency and timing division, and basically, we're very interested in the area of SDN, but also we have an element manager currently that's capable of managing all of our network elements, timing and synchronization gear. So basically, I think I'll just press into the introduction here without going through the agenda. Needed a new architecture. We looked at ONOS, and we liked the way it was architected a lot. You know, and it. I think the thing I like about it is it's a networking based framework, which there are few and far between out in the world of open source, and you know, there's several things. Obviously, you know, we like the strong support there was for it in the industry, and so on like this. So we've got two things to do then as we build this element manager, and one of them is to make it look like an element manager, even though it's built on top of ONOS, but also to find ways as we go to bring our timing and synchronization products into the world of SDN and NFV. And basically that means, I suppose, you know, having more kind of open northbound interfaces, you know, being able to present configuration of devices as services that an orchestrator might be able to bundle into a product, and so that you know, when you're creating a service graph for, we'll say, something like a 5G service or something like this, that you can include a timing and synchronization service in it, and be able to monitor its quality and SLA and all of those kind of things for managing timing flows. And by timing, I mean precision timing protocol here, and it's something that we have a lot of experience in. The group we're in used to be Symmetricon, and you know, we're obviously leaders in this field. So basically, you know, some of the features we have in the element management system are configuration GUI. There's a lot of security and role-based access control. There's a lot of alarm handling, and topology views are obviously an important point as well. Logical views and regions, and having manageable user-focused user interfaces that help them manage our gear. And so basically, we're looking to build all of these features on top of ONOS, and some parts will inevitably have to be, you know, proprietary to us. You know, like drivers and this kind of thing. We'll keep them within our own control, but you know, we will. We have the approval from the top levels that basically, if there are things that are not strategically important to us, that, you know, we should be contributing them back into the open source community. There's obviously a benefit for us in doing that. You know, there's you know, these things get a broader exposure, and, you know, if other people feel like they want to build on top of those things in a similar way, then, you know, we can all benefit. So that's, I guess, the reason why I'm bringing these things to the forum today. And I think, you know, if we're using ONOS as our code base now. We'd like to use ONOS as our code base in future, and so basically we don't want to do anything that's really out on a limb. You know, what we want to do is build code that will be compatible with ONOS going forward. So this is kind of some of our motivations here. So to jump back then just to the agenda, what I'm going to cover then is just these items. So Google Maps is the first one up, and so at the moment we have the topology view in ONOS. In fact, we have two topology views in ONOS. We've Topology and Topo2, and you know, customers ask us, you know, what about using Google Maps as a backdrop? And it's something that we have paid Google for as a license to use their maps in our product. You know, so this is something we'd be interested in seeing being used going forward. And I think it's probably something that would be a nice thing to have for other people in the topology view as well. So, you know, we've looked at various different options for us. There's obviously you can go with Google's API. But also there are other intermediate kind of layers, like say open layers, which can in fact act as an intermediary and reuse Google Maps, or it could use Open Street View maps or various different things, giving, you know, flexibility going forward. And it's a nice open source project. So one of the things we've seen there is, you know, on a rudimentary basis, we've tried integrating with the Google API, and we've found that there are we found it a bit incompatible. For instance, like you know, the background frame of the background frame of the topology view is an SVG frame, which appears to be opaque and doesn't allow you know, sort of image-based tiles to show through. And I guess, you know, before we dive too deep into it, we're kind of looking for a suggested approach. If any of you guys have any particular opinion on how to proceed with this.
On this particular topic, yeah, this is something actually I was thinking in the recent days. I mean, not specifically with the maps, but with specifically with enhancing the topology views and how to go about it with while maintaining sort of the either backwards compatibility or the same mode of use like people are used to. And I guess the idea I was toying with was perhaps just creating an alternate topology view, and what the parts that would be reused would be the backend models, which are actually used right now by both Topology 1 and Topology 2 views already, and potentially, if there is, of course, any of the front-end code that would be reusable to maintain the client-side models on a browser, but then setting it up in the context of a different view that would basically use a different technology. Because what we use, the reason we use SVG today is because that's what D3 uses, the data-driven documents JS library. We get a lot from it for free, but those things probably wouldn't make sense. Those things wouldn't be applicable in the context of Google Maps, right? You probably wouldn't care about getting forced layout, because that's something with the physical or geo map, you would most likely just ignore the forced layout aspects of it and just would want to place the nodes where they need to be according to their geographical coordinates. So I would not let yourself be restricted by the current working of the topology view.
Right.
And perhaps just look at what pieces of the existing topology view could be reused and applied in basically context of a different view. Right.
Yeah. So I guess it's I guess the thing that I see is, like, you know, we look at the I think you're kind of saying you're talking about a fork, really, Thomas.
No, I'm just talking about creating a new view, just in the UI, right? Because the ONOS UI is extensible. You can toggle between different views very easily. And so this could just present an alternate topology view, and potentially you could replace it in certain deployments, right? So clearly, our goal when we started to work on a topology 2 view was to allow to basically increase scalability with respect to human consumption. Because a very large network presenting all of it in a flat graph may not necessarily be easily consumable by the user.
Right.
Whereas, you know, so imagine having a nationwide network which has many metro network within it, and those have data centers within it. So you can kind of imagine this model of being able to zoom in gradually and reveal progressively more and more detail. And while zooming up, we progressively hide that detail. Okay. So that's why we started to do the topology 2, and the idea was that topology 2 would eventually deprecate the topology 1, and we would have just one topology. And that's still the plan. It's just that the progress has slowed down
okay.
of you know, various reasons. But that still remains the goal. Okay. But it's quite possible that you know, because of the technological choices that we made for these two topology views, that it presents challenges which are, you know, not easily surmountable, I guess.
Oh, I see.
If you want to use the Google Map tiles or similar technologies. So I would not let yourself be restricted. And if you think you can just come up, create a new view that can be just selected among many others, go ahead, proceed with that, and then reuse pieces from the back end and front end as applicable. And then we would figure out how to, most likely in that deployment, you would probably even hide the other two views that we have.
I see. Okay. Okay. Yeah, I think I understand. You know, so basically, it's a matter of start with a clean sheet and get those image or tile-based map views going in a view, and then figure out basically how to bring things over into it, or how it could be backported into an existing topology view. Okay.
Right. Yeah. But just to be clear, I mean, clearly, if there is a way for you to integrate with the existing topology view, I would definitely encourage that. But if you see that it's not easily done, then I just want to make you aware that you shouldn't be shy about creating a new one. That's all.
Yeah. Okay. Okay. Yeah. We'll have a go at that. Okay. Yeah. Let me see. Yeah. So this kind of really is a follow-on, I suppose, and a continuation. I think you've answered it. You know, is there a plan to merge them, and basically, is there anything we can do there? You know, I think one of the features that we liked in topology was the way alarm summaries are displayed. You know, with that kind of there's a bubble kind of icons showing alarm counts and that kind of thing, and I presume like that's all in the topology model. It's just a matter that it's displayed in topology view, but not in Topo 2.
Yeah, Topo 2 was primarily it's lagging behind, basically behind the functionality. But the goal is to, like I said, to completely replace the original one. And effectively, if you don't set up regions, if you don't partition your network model into regions through configuration, the idea is that you would basically get the same functionality in a flat view as you would today with today's topology view.
Yes. Yeah.
Right?
Yeah.
Once you set up regions, now you suddenly reveal this additional layer of functionality through which you can zoom in and zoom out, and potentially offer alternate views, right? Alternate views of the same region. Because you can imagine that one might want to see the fabric network, you know, in a kind of a classical logical layout of spines and leaves, kind of a layered logical view. But you can also imagine that now let's view that in a more of a physical view, where you actually want to see it, how it looks like when it's laid out into a data center floor plan.
Yeah. Yeah, yeah, and we've experimented with that, and there's good examples there on creating objects, dividing them up into regions, and the navigation and everything works, I think, in a satisfactory way. So yeah, okay. I think it would be a matter then of if we want everything to appear on Topo 2, it would really be just a matter of trying to port those features over. Okay.
Exactly. So if you, since you ask where you can help, I mean, if you choose that, if you decide that the Topology 2 would form a good basis for developing your functionality, then definitely jump in and help out in developing that functionality. Because currently the Brigade is, I think, Brigade 01. And Stephen, who's actually based in UK, I don't know if you've met him at...
no, I haven't met him, but I was aware of him. Yeah, but it would definitely be it would be interesting to get in touch with him about this kind of thing. Do you know if he's actively working on Topo 2?
In a previous sprint, there was work done. I'm not sure about this sprint. I mean, just right now, you know, one person, and he has clearly other obligations from his company. So it's right now it's kind of moving at a trickle pace, unfortunately.
Sure. Okay. Okay. Let me see then. So yeah, this was the subject here is a widely distributed cluster. So I guess we're really attracted to the clustering solution and the high availability and resilience that ONOS gives with the distributed data store. Previously in an EMS, we had an active and a standby node, and really customers wanted to be in a situation where they could distribute the load across servers. And, I think using clustering, this is possible with 3 nodes in a sort of an active configuration. And it meets our needs for resilience. Now, the question would it be possible to distribute these over a wider geography, because I think, it would appear appealing to customers that have, operations divided up across regions of a country, would like to improve their resiliency by having nodes in different geographical areas. And so I guess we've had some technical questions about this. We tried it before on an older release, and we set timeouts higher. We weren't really sure if we got them all, and we weren't really clear what the failure modes were. It's obviously a very complex piece of technology that's going on in there, and I don't think we got to the bottom of what were all of the things that were happening when we were on a widely distributed system. So basically, I think Jordan said he was going to dial into the call. I don't know if he actually joined.
Yeah, unfortunately he wanted to, but unfortunately he got called on to help with the deployment. So he's not, he's back east now, and he's with the customer effectively.
Right.
So we should probably at least continue a portion of this discussion later time, offline perhaps, or in another meeting like this.
Yeah.
But some of the topics I can cover. That's, I mean, the notion of regions is precisely, it was introduced precisely for this, is to allow kind of to control at least the mastership relationships between the controllers and the nodes in a way that would align with the geographical boundaries. Because you may have some sort of a division in your network, which is kind of would be considered kind of a weak link, right? For example, you can talk about a cluster of buildings in one campus, another cluster of buildings in another campus, perhaps connected using some sort of a tenuous link, and you would want to both of the campuses to be able to operate if that link gets severed. Now, if you squint and right now forget about the data store itself, this certainly should be possible, because as long as the cluster is set up in a way where mastership can be kind of affinity to the aligned with the geographical boundaries, then you should be able to operate. However, the problem comes with aligning these regions also with the partitions of the distributed store, that becomes much more complex, and this may be something that we should probably bring Jordan in, because I'm not an expert in this area. I might be overlooking some fundamentals. Clearly, at least at a high level, I know that this violates this principle that we have today with ONOS, which is the majority-minority, of basically the core notion of a quorum within a given partition would clearly be violated, and you would have a portion, at least with things as they are today, you would have a portion. You would have one campus that would be operative because it would have a majority, and the other one wouldn't, right? And the same can be applied even if it's spread out. You simply are going to have some asymmetry, especially if you have an all-size cluster, as we recommend. You're going to end up with at least one network partition. You're going to end up with some asymmetry, and the environment which is sitting on a minority side of that partition would simply become now inoperative, or at least would become read-only.
Yes, yeah, and I mean the nodes though that would have been managed by that would continue to be managed by the other side, by nodes in the other campus, I guess. Would they not?
Well, again, I don't think without modification, because today I think the moment the nodes who find themselves on a minority side of a network partition will basically relinquish mastership.
Yes, yes. So mastership of those will go to the surviving side, if you know what I mean.
Correct, but assuming that you have a tenuous connection between the sides, the devices are going to be also on the same side of a partition. They're going to be away from the minority, and they're going to be stuck with without effectively a potential master. Right? Now, there's no problem with physical connectivity on the controllers and the devices which are on the same side of the partition. However, from the logical notion of the leadership, they won't. It's like a bureaucratic error, effectively, right? So no, you can't manage them because you don't have majority. Well, I can see them and nobody else can. So the whole idea of regions was introduced to kind of help guide that and to kind of overcome that bureaucratic error. But I don't think, at least today, with the way the mastership subsystem works, would accomplish that. And so, but it's not to say that it couldn't with some changes, right? This is basically where we could potentially voluntarily allow the machines, given a specific region configuration, we could allow the region to continue its own mastership, even though it doesn't have majority.
Okay.
That will require further discussions, and again, I might be overlooking some fundamental stuff, and for that, it would be great to have Jordan in the room.
Yeah, yeah.
There's also be considered probably which type of network you're using between the controllers itself. If it's just pure management, then you have guarantees of delivery of all the messages with very small delay. Instead, if you're going in the existing network for control traffic between the ONOS instances, you might hit some problems due to sharing the link with existing packets. And that might also cause some timeouts and errors. So we might want to take into account also that.
Yeah, I was assuming that we're here just talking about really the management network in the first place, because we're talking about a realm of management, and whether or not it would be separate from the other kind of more production network, or whether it would be the same.
Yeah, well, I guess what we're sort of asking is what are the what are the boundaries of what's possible, and if it's the case that it needs a dedicated management network, with resiliency to connect to different campuses. Well, that's just a data point that we'd like to sort of understand,
Yeah, and there may be two aspects to this. One would be with respect to just operating across, operating in face of failures or network partitions. That may be more complex problem to solve, and also kind of the regular nominal state, a running state problem of running across network which has perhaps higher latencies than a collocated network might. And so this is something that you allude to with your setting timeouts and other things like that. And that one might be easier to overcome by simply tailoring the tolerances.
Right. And I guess that's like that's kind of what we'd be trying to understand is what is it dependent on, and you know, like I said previously, we're not sure we got all of the timeouts properly, and you know, are there some other things we should have considered? So it would be interesting to talk to Jordan about this as well.
Yeah, and we could certainly then talk about how potentially the partitions, the setup of the partitions within a cluster could be guided by the region configuration as well. Because right now it's almost, you know, it's very kind of uniformly spread out and loaded.
I would also think that gathering some of the data of the tests that you've done with a dump of the timeouts you changed, of the devices, of the partitions, of the masters and the leaders, I would think it would clearly help Jordan understand better a possible deployment scenario.
Yeah, we were hoping to get it recreated for this meeting so that I might have those figures, but unfortunately, we just ran out of time. You know, we had done this on an older release, and we wanted to bring it up to date and see what the results would be on the latest release, but we didn't get it done in time. But on the subject of partitions, Thomas, this is not something that's familiar to me. Is there a guideline document on that partitioning somewhere in the wiki?
You know, I'm not sure off the top of my head. We can probably find out and let you know. I think Andrea is looking right now.
Yeah, maybe.
I wouldn't be surprised because Jordan is a prolific writer. So.
Okay, that's good. That's good. Yeah, either maybe something is even in a Google Doc would help us understand what's required there as well. Okay.
I'll know that, and we'll get you what's available.
Thank you. Okay.
Oh, one question. So when you say wide geography, what kind of scale are you thinking about? Is it like widespread inside the UK or across country in Europe or even across Atlantic? What kind of scale do you have in mind?
Yeah, so the example I was given was the Scandinavian countries, that many that some operators would operate the Scandinavian countries, Sweden, Finland, Denmark, as you know, they'd have one network across all those three countries, and you know, they would have different NOCs for each country, but they want to keep the network managed as they want a super NOC, I guess, you know. So they would like to see it as one cluster. So it's that kind of region. Yes, it is inter-country, but it's not transatlantic.
Yeah, and in cases like this, you know, we have to always ask ourselves if federation would be a better method to go.
Right. Yeah, indeed, it might be. And if that's the, you know, if that's the conclusion out of this investigation, then, you know, we'll just consider this. You know, that's where we draw the line, and if it's beyond a certain distance and beyond a certain latency, then federation maybe is a better solution.
Okay. And it also has to do with other things too, right? For example, if you're talking about different administrative controls, then you probably want to divide it into separate realms, which are then federated.
Right.
Either in a peer-to-peer relationship or a hierarchical relationship.
Okay. So in terms of federated infrastructure, what is there at the moment in ONOS? I think I've seen Icona as a sort of an interface between instances of ONOS. Are there other tools there as well?
So as far as I know, ICONA is kind of the first and only manifestation of the federation within ONOS. And now it's a peer-based federation, where basically one control domain exposes itself as a set of devices, kind of logical devices, to another control domain.
Okay.
And this way you can kind of virtualize and hide some of the internal structure and expose only the endpoints of the network that you care about, and potentially the infrastructure, interior of the network that you care about exposing.
I see. I
And
see.
in the simplest case, it would be basically the one control domain would expose a big switch to another control domain with endpoints that are to be accessible.
Yeah, and I think that here you might require some sort of lower level details than what ICONA offers at the moment. I don't know.
Yeah, so we'll have to, again, this is something that would have to be explored more.
Yeah.
Because in my mind, you're actually looking at sharing all the information.
Yeah, so that's right. So one of the virtues of federation is that it allows you to mask certain level of detail and kind of hide implementation of one control domain from another, right?
Okay.
And so it gets you scalability, it gets you some ability to observe differences or failures in a local context, well, hence federation. And so it solves a couple of problems. Plus also it's a good isolation mechanism for different different administrative domains, right?
Yeah.
A set of different sort of privileges within that control domain and globally. And it's something that you would generally, in a different control, in a kind of heterogeneous admin control realm, you would probably want to use peering federation because there's no one boss.
Yeah.
They're all just peers. But if you're talking about a single administrative domain, which is divided into multiple different control domains, you still get the benefits of scaling and hiding the levels of detail, but now you can organize them in a hierarchical fashion, and the top level entity is just simply kind of the high level leverage that you can pull.
Okay. Okay. Yeah, that's an alternative to consider. Yeah, very good. That's good to know. So really, it's information gathering at this stage, but there's a couple of good pointers there. Anyway, will allow us to think about it. Okay. Let me see. So then I guess one of the next things I wanted to talk about was a configuration GUI, and recently I saw UTA's proposals on DCS 2.0, and I started thinking to myself about, how would we go about building a configuration GUI generically from, and possibly even base it off RESTCONF. So I had this, I prepared this separate slide pack, and I've been working on a prototype which I can show you as well. So let's see. So this is the configuration GUI. So let me just put it into presentation mode. So it's something that let me see. Like if you consider the RESTCONF interface, it's obviously driven by Yang and the attributes you can enter, and the JSON you form is informed by Yang, and that's not just in ONOS, but in general for RESTCONF. So if you're doing a GUI and the GUI is going to be driven by that Yang, it has to have some way of receiving that metadata, shall we call it, from RESTCONF, and I think UTA proposed a meta branch here for doing this, but it could be something that's based off a file as well, and in the prototype I just based the thing off a file. But it's something the ONOS Yang tools probably could do, is to produce some kind of metadata description equivalent to Yang in a JSON format. So basically, you know, this basically defines what are all the containers and leaves and lists and all of this kind of stuff. You know, I think the other important point to consider is the complexity of Yang. You know, there can be nesting and augments, choices, there's patterns, ranges, and so on like this. And one of the other sort of requirements that I saw was that in DCS2, I think UTA proposed where multiple changes would be considered together, and they would be considered as a patch. So it's not just enough to have a GUI that changes one attribute at a time. You know, it must be capable of changing many attributes at a time. So this is kind of like, I suppose, a set of constraints or requirements. It probably could be more clearly stated. So in thinking about it then, I thought that what's actually required, rather than starting at the top and having a top-down approach, that I thought, you know, maybe it might be worth building up a set of components from the bottom up, and make sure each component is well behaved and really represents the really creates a solid component that you can build a GUI system out of, because you know, GUI systems, everybody has their own requirements on them, but I think if the components are solid and reusable, then you've got something that you can you know, aggregate these things together in. So you know, I think there would be components for container, for list, for leaf list, and so on like this. You know, and a container obviously can contain other containers and lists and leaves and so on like this. And lists can be very complicated with multiple containers and or more lists and so on. So it can get very complex. Choices have to be handled, you know, and then there are actions or custom RPC actions like you reboot or set time or this kind of thing. They also have to be handled, and they can have a list of input and output with their own containers, leaves, and so on like this. So I mean, I think you know, the nice part about this is that Yang is a bounded problem and RESTCONF is a bounded problem, and creating a GUI out of them should be a bounded problem too, if we just think enough about it. So then, you know, there's a subject of editing leaves, and so leaf values are where numbers and character strings are entered, and you know, there are multiple constraints possible on those, and I have not seen any netconf editor or RESTCONF editor or anything like that to date that takes into account patterns like string regular expression patterns, length restrictions, you know, ranges, decimal values, you know, all of the different combinations, drop-down values, bit values, union values, you know, all of this kind of stuff. You know, there's specialist types like Yang identifier, IPv4 and IPv6 addresses. So these are all considerations to take into account when defining a user interface. So what I was kind of thinking then is, you know, if you were to base it off RESTCONF, you would have the meta providing a metadata description of what the system can contain, and then you'd have the data with the values and list entries of what it actually contains. And so the idea is that, you know, this provides the metadata, this provides the configuration, and you bring them together into something that can view configuration and state, you know, using these web components, these Angular web components. And so basically what I'm proposing is like a set of components like container, list, leaf list that you can reuse, you know, recursively if you need to, depending on how the Yang model is structured. And then, you know, it would handle all of the posts of the changes back down to the data URL or resource within RESTCONF again. So really, you know, I guess what I called them in my prototype is the Yang meta service and the Yang data service, this representing the structure of the model and this representing the actual configuration. So really it's, you know, there can be gaps in it, there can be a list and there can be many instances of a list, or there can be 0 instances. You know, there might be some leaves that have no value or might have mandatory values and so on like this. So I think, you know, in terms of how it would work, you know, scaling, I think, is one of the biggest challenges. You know, that it's got to deal with long lists, and it's got to deal with, you know, long text strings, and it's got to deal with short ones as well, you know, and you know, nesting could be unlimited, and you know, on the other hand, then you don't want something that's too sparse, you know, that requires excessive clicking and navigation, you know, when it's not warranted. So really, you know, my thoughts on it, and these really are, I'm really open to suggestions on this, you know, as to how this is really how they would be arranged into a system. But I think what I want to say is that my first objective is to talk about individual components that can be assembled by different people into different systems. So this is just my kind of opinion on how systems might be put together. You know, don't clutter the screen. You know, descriptions and references are handy when you're editing something, but you don't want to be looking at big long descriptions of things. You know, maybe you truncate them. You know, you want to see units, icons, and colors where possible instead of words and so on. And so, you know, I looked at Open Daylight, and it has a configuration GUI. Again, you know, I found that you know, it's very much tied to RESTCONF. For instance, like attributes are settable only individually, from what I could see. I found it very hard to navigate, very hard to understand what's going on. And again, you know, I think part of the problem is that you're exposed to everything here, whereas what you really want is, you want to configure your device. You don't want to have to, you know, remember all the names of what everything means, and this is, you know, text heavy and driven by text here. So this was, and really, you know, to the average user, you know, using our element management system, you know, you don't want to be presenting things like get, you know, post, all of these kind of things. You don't want to be exposing that level of technical details to them. Let me see. So I was just going to talk about the prototype a bit. So basically, I built this thing on Angular CLI, and so you probably saw the screenshot I did here. So I'll jump over to it if that's okay.
Yes.
So I've got it running here on Angular. I've got the GUI screen. Let's see. I don't know if I'm able to share it. Oh yeah, here we go. And then the other thing I wanted to do was, let me just hide this. Is just talk about so I created this test 1.yang, and I created a plugin for a tool called pyang, and with pyang I converted it into a JSON format. So basically, there was already a plugin in pyang called J to X, and I extended it, called it J to XX, and basically it produces this JSON then that reads everything. So for instance, like, you know, we've got range restrictions on numbers and so on like this. So when I have this demo. This is running on my machine through Angular, and what I have here is like if I want to edit this value here, it picks up the range automatically from that RESTCONF, and it picks up that it's a number. You know, I can increase the range, or I can increase the value, and it shows me straight away it's out of range. 13 is okay, 12, 11, but 10 is not, because it's not in the range, you know, 1 to 3 and 11 to 13. So this is the kind of thing I'm talking about, building from the bottom up. You know, so for instance, I have a similar thing for text editing. You know, so this one I think has a length restriction. Yeah, so basically I have a length restriction there that it must be between 5 and 10 characters long, and you can apply things like patterns as well, like regular expressions, and they're used you know, for many different things, like maybe interface name or something like this, depending on how they're specified. That was one of the kind of objectives I wanted to achieve with it. But basically, what's happening here is it's reading in the metadata. So what I have is I have a metadata service, which is basically reading from a location like oh, sorry, I don't have it there. Do I? I don't. No, excuse me. I'll just go up here. Yeah, so it's reading from RESTCONF data meta test 1. So I've got kind of an interceptor here that basically mocks up that web service and just gives it the JSON file. So basically that's what's driving this GUI. So one of the things I wanted to do is, I showed you previously like how you know, I can edit individual attribute values. This one here is the config value. Let me just bring that up there alongside it so we can see. That one is a read-only. Leaf 2C is read-only. But what I've done here is that I have this kind of hierarchical thing, so that if you, for instance, want to edit container 1A, it changes all of the leaf values beneath it into editable fields, and so basically, you know, when I click yes, then it should create a payload that contains the changed values for all of those leaf attributes. Now that's not working at the moment, really. I just have to the submit isn't working. I haven't got that far with it, but basically it's I just cancel it and it brings it back into this mode. But I think the key kind of point here is that, you know, when I click on this one, it's just editing those two fields, but when I clicked on this one, it's editing those two fields and the lists as well, and even the string value down here. And what I've done is I've removed the pencil icon from this one now, because it's being edited as part of a larger context. And similarly with lists, you know, I can add a list, and it prompts me with a new key value and a new number value. Let me just cancel that one again. Removing things is different. It's not possible to add things and remove things in the one RESTCONF transaction, because of course they're different HTTP actions. One is delete, and while the other is post. You know, so there are some limitations on it in terms of what you can do. So, like for instance, this one reduced or removed that TX out 1, and I'm just left with TX out 2 now. But I guess really that's about the size of it. This was an example of more read-only stuff, and well, you can see the values here. You can see list 2B what's actually happening there is as I hover over the title of the leaf or the list, it's giving me the description field from the Yang as well. So that kind of prompting is there, you know, and that carries all the way up through containers, leaves, lists, and so on like that. So I guess you know, the reason for doing it was to, and bringing it up in this forum, is to elicit kind of feedback from you guys and see what other requirements there could be out there for something like this.
I mean, I think this is pretty neat. I don't really necessarily, this is not something that I spend much time thinking about. I guess we're at a little more rudimentary stage for the DCS.
Yeah.
I think why certainly makes sense because the metadata is there that describes the structure of a model, and be able to edit it would certainly be very, very nice. So it would be certainly very interesting to have a to see this embedded inside the ONOS UI.
Okay. So you know, I think the next step for me is to see how I can take this out of Angular CLI and bring it into ONOS, which I think probably shouldn't be too much of a challenge. You're already using Angular components inside ONOS already. Would you think it's doable?
Question?
What do you think?
My question is, how does this UI react? When you edit the certain value, you immediately posting the changes to ONOS or whatever underneath RESTCONF, or are you simply staging the changes inside the UI?
Yeah, so for the moment, it's at a pretty rudimentary stage, but what I'm doing at the moment is my Yang data service. Really, this is it. You know, so what I have, how I relate the metadata to the actual data is just by listing them out as distinguished names with their actual value. So the idea is that yes, I would stage them in here in this map. And I think I would have a map then for the changed values, and you know, or else some kind of a flag that's holding a list of changed values, and when it comes to time to submit, that it would assemble them together into some kind of a JSON payload and transmit them down to RESTCONF.
Yeah, that really makes sense. Yeah, that kind of interaction is probably likely to be the real world situation where you make a series of changes, check what changes you actually made, then actually commit it down to the system. So yeah,
yeah.
Yeah.
And like I say, there is some limitation on what you can do, you know, with RESTCONF. You can't create attributes and delete attributes at the same time because they're really just different actions.
Sure, but my suggestion would be to still kind of to collect the changes into a bag of potentially what might be a bag of distinct RESTCONF operations, but they could be still committed, at least from a user standpoint, at the given point in time, only when they're ready to commit them, right? So even if they click on deletes and some adds and deletes, and later we should be able to view the changes or see what has changed, and then when they say OK or save it, then at that point in time the barrage of the RESTCONF operation, whatever other operations could be issued.
Yeah.
And that way, an option of canceling out of them and at least doing things in reasonably narrow time window.
Okay. Yeah, that's yeah. So I think that's a good idea. That's have some higher level thing that would allow you merge or sort of keep several changes together. In the in the world of what's proposed for DCS2, I guess they still would be regarded as each RESTCONF operation would be regarded as an individual patch, I guess. Am I reading that right?
Yes, that's the intention. The DCS2 design is to enable such kind of use cases where you touch all over the trees and just send a collection of operation in single shot.
Okay. Okay. So I mean, I guess if there's, I'm hoping there will be somebody else interested in this, in the community, interested in this kind of level of functionality as well. You know, that it does, I think, give ONOS and DCS kind of like certain functionality out of the box if there is a Yang-driven GUI for it. You know, I think I'm hopeful that somebody else will be interested in it, and that you know, we can get a wider set of requirements from maybe other people as well. Do you think that's possible, or how would we go about sort of shaking out the trees for those kind of things?
I definitely agree. I think if this is introduced, I think at the time you get it to the point where you're comfortable to changing it from the Angular CLI to basically an embedded view, then I would for sure go for that. And we just add it as an additional view inside the ONOS UI. And one thing we have to deal with is this scale, right? Because with ONOS UI, we kind of, with ONOS DCS, we're kind of providing this logically unified tree for all of the configurations, for all the devices and all of the services. And as such, presenting is, if you were to flatten that into this insane view, that would really become a huge scalability challenge. So possibility might be to at least initially just to, you know, narrow it to a specific service, specific device.
Yes, yeah, definitely. I mean, I think that's the kind of things that those limitations are there with RESTCONF anyway, as it stands at the moment. You know, it's per device and per service within the device. You know, there isn't, as far as I know, a kind of a global view or anything like this. You know, but again, you know, that's a kind of a system level, you know, problem, I guess. You know, I think getting the components and getting all of the different data types settled is one of my first concerns here. You know, that you have like quality components that can allow you to validate against range and length and all of those kind of things is important as well. And different people might compose them in different ways.
For sure.
Okay. So if I was to sort of get this working on ONOS, do you think it would be, should I keep it in a separate repo or put it into the main ONOS repository?
So we're going to start the task of repository disaggregation, but I would suggest you don't wait for that. So for now, I would suggest you put it under apps somewhere.
Yeah. Because
we already have a kind of a Yang GUI, right? Which right now it just presents a single tabular view of all of the registered models and supports drag and drop to enable the live compilation. So you can actually drag a Yang model or set up or tar of Yang models onto this, and it will compile it and register it. So either add it as a second view in that existing application, that might be one possibility. Or if you want to have a little more autonomy, you can add it as a separate application. Okay, Yang editor application. It's up. I'll leave that up to you. Whatever will give, whatever will leave you least constraint. We can always combine them or partition them later if necessary. So it's up to you. But I would put it under the ONOS apps. Whether you use your own app or whether you register it on the existing Yang GUI app, it's up to you.
Okay.
Yeah, and clearly, I would think about how you want to solve the, I guess, the entry problem for the user, where, how do they select which device or which service they want to edit? The kind of the top level node, and then you edit from that point below. Because otherwise, it will probably not be a very scalable solution.
Yes, yeah. So I mean, you might take it from the device's tabular view or something like this, and from that point, you might enter the configuration, and you might decide which part of the configuration you're doing. Is it interfaces or system or something like this, and then bring up this GUI in the context of what you've chosen.
Exactly. Yeah.
Yeah. Okay. Very good. Let me see. So I think that was my last slide on that one. And I have the code as it is at the moment, saved in Git on a public Git. I can share that with you afterwards if you want to have a look. And eventually I'll be porting it into ONOS. I see we're almost out, or we're over time. Really, is there time to continue, or is this? I have a
little bit of time. I think, but Andrea has to head out, and Ian already had to head out. Okay. So, do you want to maybe schedule another session to talk about some of the scalability stuff?
Well, yeah, maybe we should. Yeah, this is it. Maybe we should. I mean, they're not something that are as pressing as the others, and maybe we can get answers to those over time.
Okay. Well, great. This is awesome, Sean. I'm glad to see you guys having chosen ONOS as your basis for the element manager, and I'm looking forward to seeing all of these contributions in ONOS code base. That's great.
Well, yeah, and from us, I want to say thank you to you guys, and the support we've had with you has been fantastic to date, and we're very appreciative of all the help and responses that you've given us, and yeah, we can follow up with emails on some of the subject matters we talked about, and hopefully we'll be able to get together with Jordan on the distributed cluster question in the next couple of weeks.
For sure, we'll have to do that.
Sounds good.
All right. Well, thank you. You have a great day, and talk to you later. Bye-bye.
Yeah. Thanks, guys. Bye-bye.
Bye.
Bye.